Good afternoon, everybody. Seem to have quite an attendance. Welcome to this Skarn webinar. It's called Understand Water-Related Financial Risks in Mining and Metals. My name is Raymond Philippe. For the last 3 years, I am the head of water at Skarn Associates. My background is about 25 years in consultancy, process design, engineering projects related to water use in the mining industry. I've worked on water supply, desalination, effluent treatment, as well as climate change impact, water risk evaluation, and water strategy development for mining companies. So, as I mentioned, understand water-related financial risks in mining and metals and mining. This is not a new topic, but the way we have been working on it at Skarn is probably new for a lot of people. Let me first explain what we do at Skarn in our concept and methodology. So what we work on, we develop benchmarks and contextualize water performance for mining operations, mining companies, and we do that through quantified asset level water use data analysis. And through the quantification of objective metrics, it gives us the possibility to do the comparison and make it consistent among operations globally. And it also makes it fit for diverse groups of stakeholders, in this case, not only for mining companies, but also the financial sectors, commodity buyers and commodity users, as well as regulators. The way we work on our data sets, first we take our mine production database being developed at Skarn Associates. We overlay that with asset level annual water balances that we update twice a year. We put that into asset level operational context. I will come back to that in just a bit. And we also overlay that with some georeferenced historic climate data, and that gives us an indication about exposure related to water availability, drought and floods, for example. And the outputs that we get from the methodology is we have a good view of water use at commodity level, on environmental impact of water use, and on financial impacts related to water use or lack of water, or excess of water, where water is a direct driver or an enabler for revenue generation. I would say in relation to water management, it is a challenge to go from a very technical, quantified water balance asset level to a translation into global trends related to commodities and risks for the mining industry and the financial impact. And that is where we have been focusing on. If you see on the left side, this could be a typical water balance from of a mine site. And how the question is then how to convert that into physical risk, regulatory risks, reputational risks, quantifications, and then to convert that into financial impacts such as higher investment costs, increase of operation costs, revenue impacts, and so forth. What we do for that is, first of all, recognizing that water risk exposure is a local impact. The water use, the water is being captured locally and discharged locally at the mine site or in the environment of the mine site. And we have to take into consideration quite a number of exposure factors, such as the mine type, the type of process of the concentrator or a leach operation, for example, the size of the operation and thus the amount of water associated to that, the climatic conditions, as I mentioned before, operational efficiency, and a very important one is, in fact, what you see on the right side, and the sources of water. What we have shown here is on the right side. It's a data set of approximately 200 copper producing mines globally, where we have differentiated the types of sources that each of these mines is using, in this case 2023, when it comes to surface water, when it comes to groundwater and seawater and wastewater. And as you might expect, not every type of water has the same climatic exposure or has the same exposure to, for example, social risk or environmental risk. And that's a consideration is very important if you take into consideration afterwards how to calculate the financial risks associated. That risk, water-related risk exposure, and the quantification of that, as you can see here, that it's also a location-based risk. On the left side, we have again copper, the regional copper supply from the same data set, split out according to the location, the continent where it's being produced. And on the left side, you see the associated aggregated total production at risk for each of these continents or the aggregate operations in each continent. And on the right side, you see on that graph the total amount of water that is being consumed per ton of ore being processed. And there are a couple of very interesting things that you can see. First of all, the total global copper production currently, almost 8% of that is currently at risk for not being produced due to directly related water parameters such as drought or flood. The continents, the regions to the left of the global copper production, you see that in general they have a lesser amount of risk, and associated to that you see also very often an increased amount of water being consumed at each site. And that means also that the exposure to eventual risks is aligned with that. So if one of these operations comes into a situation of risk, then the risk is immediately increased by the amount of water per ton of ore processed. The regions on the right side, as you can see in North America, South, Central America, and the Middle East in general are more drought exposed regions. And they have, because of drought, a higher production at risk exposure. And in the past, what you can see also is that these regions have done quite a lot of work on being more efficient in their water use. An interesting case in this specific case is North America, that has a very low water consumption rate. And that is very much associated to the type of process that is being operated right now. The majority of the North American copper production is through leach operations. And the challenge there is going to be once the oxide minerals are being depleted and are being replaced by sulfide mineral, that goes also associated to a change in processing type, and that process type, such as that includes tailings generation, will also immediately increase the amount of water being required for production. So my take on that is that in the upcoming years, when oxides are going to get depleted, the demand for water, especially in North America, is going to increase. The same amount of the 200 assets, about half of them, just over half of them, are exposed to any water-related production risk, flood and drought. And you can see that split in the right side of the slides. Important to note that the vertical axis here represents up to 10% of total production, and that's related to flooding. And the horizontal axis relates to drought, and that goes to 40%. And the copper industry is typically a more drought-exposed industry than a flood-exposed industry. For the financial sector, the challenge is where to get the data from related to water use in the mining industry, how to convert that into metrics that are meaningful to the sector, and to make sure that that is related really to what's happening at the operational level. And when I say operational level, that is important for a couple of reasons. First of all, there is now a requirement on reporting in IFRS S1. That's a sustainability requirement of the International Financial Reporting Standards, that an entity shall not aggregate information if doing so would obscure information that is material. And basically it means that for any company that is required to report under the accounting standards IFRS, it requires to validate whether or not an aggregate value is acceptable or not. In this case, in the graph on the left side, I've split out the copper producing assets of several of the major copper mining companies, and what you can see here on the vertical axis is the intensity, the water consumption intensity, compared to the benchmark of the total amount of copper producers globally. Where P50 in this, of 50% here, would be the average of the total amount of copper being produced with that consumption intensity. As you can see, not all of the mining companies have a single dot as the average water consumption. They all have a bar, and the extension of that of the vertical bar relates to the difference between the water consumption intensity of the lower or the better operating assets compared to the more water consuming assets. And as you can see, the majority of the operation of the companies have very poor operating consumption, water consumption assets, and very good water consumption assets. And on the right side is the table that goes with that. So if, the majority have, it goes between 2 and 10 operating mines. And with the owned production and the operated versus owned indicator. And with that, I mean, when a mining company reports their water use in their sustainability report, for example, and they do that on the basis of the amount of the assets they directly operate. But that doesn't necessarily mean that they also own the copper that is being produced at each asset. And the operated versus owned difference that you see in the last column in the table refers to that. Interesting, for example, that Rio Tinto owns 69% more copper production than what it reports on from a water use perspective. And that specifically relates to the Escondida mine, where they have a big chunk of, but are a minority shareholder. Others, for example, Glencore, Teck Resources, have similar situations where they have minority stakes in several mining companies or mining operations, and they are not directly reporting on that. Another interesting case is the case of Antofagasta and Freeport, where they both have more representation in the operation than in the ownership of the mines that they operate. And that's being shown in the different colors of the dots here, in the consumption, water consumption benchmark. And the darker dots represent the operated water consumption. So that is the water consumption for each of the operations that they manage. But the total owned water consumption benchmark, and with that, the exposure to any water-related risks, is associated to the reddish colored dots. So that's especially for a third party stakeholder, a financial sector, for example, that is important to understand that difference, because that can be substantial. I already mentioned IFRS, the International Financial Reporting Standard. That is a standard that now has also incorporated the TCFD, that's the Task Force on Climate-Related Financial Disclosures. That's maybe a term that is more familiar with within the mining sector, because let me put it this way: over the last year or two, there has been a very strong push on renewing or adding new reporting requirements for not only the companies themselves that operate the mines, but also for the financial sector that has a stake in those mines. As I mentioned, so we have the IFRS that requires an entity, for example, a financial institution, to disclose information about any climate-related physical risks such as water availability. I just showed that in the case of copper, that can be the exposure to production risk can be important. And the European Union is also rolling out several standards related to the, sustainability reporting, but some of the topics in there also have the requirements to report on quantitative information about potential financial effects of material risks and opportunity arising from water and marine resources related impacts. And interesting there, this not only relates to the direct impact for the mining company, but also how the mining company might be impacted, or any company might be impacted by water use from its stakeholders in the from other stakeholders in the area. And another interesting financial parameter associated to water use is, this is a sector agnostic indicator. It's the financial water efficiency set up by the United Nations as one of the sustainable development goals, and specifically 6.4.1. I'm going to have a slide on that here. This SDG 6.4 states that by 2030, substantially increase water use efficiency across all sectors and should ensure sustainable withdrawals. We're talking now about water withdrawals, not water consumption, and that's important to note. Second, we have on the left side a graph showing how in time the financial water efficiency, using the definition from the United Nations, evolves in globally and specifically on the several of the commodities that we are looking at with Skarn. Interesting there to see is that where the global average SDG 6.4.1 efficiency is, it's an expectancy of having a revenue generated of about $21 per cubic meter of water withdrawn. Interesting there is that to show that the depending on the commodity that you're looking at, copper, gold, and zinc is what is being shown here, and those water efficiencies are very much higher, but they are also, there is a lot of variation in time, and that, especially in the case of gold, for example, is very much related to the gold price. So the water efficiency is directly related here to the revenue coming out of the product that is being generated here, and in the case of mining, that can be substantial. I mentioned also one important point on the left side as well is that there is a lack in data availability on the publicly available UN SDG financial water efficiency data, and what has been published so far is up to 2021. And with Skarn, we have been able to develop a methodology that is not only giving the data up to 2023 now, but we're also starting to do forward-looking financial water efficiency impacts into the future. And with we expect to come out with a new product and the update products in the next coming months that is going to do a forward-looking up to 2030. I also mentioned that there is a big difference between withdrawals and consumption, and especially in the mining sector, where typically a mining operation is very much exposed to water availability in the surrounding because of its size and impact with water, with runoffs, precipitation, snow melt, dewatering, and what happens there is that typically the amount of water that is being withdrawn, that's being captured, is maybe very much higher than the total amount of water that effectively is being consumed, and with the difference being discharged back to the environment. So there is a problem, or at least a footnote to be made in when you're using this specific financial water efficiency declarations, that in the case of mining, you might have a different view. In the graph on the right, there is the diagonal line here in this one relates to those mining operations, in this case gold operations, that have zero liquid discharge. So they have all the water that they withdraw, effectively they are discharging to the environment. Sorry, they're consuming, they're not discharging to the environment. All the assets that are to the right of that this specific line, they have a much higher withdrawal than the water that they consume, and they discharge that amount of water. And that has directly an impact on what you see here on the left. If you take into consideration this aspect, the financial water efficiency based on consumption for the mining sector and generally is much higher. Also important to note that there are a lot of targets being set globally around net zero, and our statement here is that net zero is also water dependent, and where water is at the center of mineral supply and demand, and of finance and of sustainability. To come to net zero emissions and to control climate change, you need critical minerals such as copper. But copper, as we've seen, also requires water. And that water security is being impacted by climate change. So somehow we need to break this the circle down, and we have to understand what the size of that circle is. To have an understanding of that, compared to the 2023 baseline, the International Energy Agency expects a close to 18% additional primary copper requirements for meeting the 2030 targets to come to net zero 2050. And based on the current consumption of water, that would mean an additional 18 cubic meter per second of additional water in a sector that's already pretty water stressed. As I mentioned, 40% of copper mines globally have already over 5% of the planned copper production at risk. And the total 7% of total installed mines and processing production capacity is exposed to that risk. The existing mines are facing a situation of a declining ore rates and process conversion, as I mentioned in the case of North America, and that will increase the water requirements for copper production. And new mining projects are being challenged by obtaining permits and social license for obtaining a steady, sustainable water supply. With that, I'm ending with my final slide here with key takeaways. So the last slide, water is effectively affected by climate change and is a resource required for net zero critical minerals production. Both metal supply and demand are water dependent and exposed to water-related risk. We've seen there's a new, quite some new regulations coming on in play that require, especially for the financial quantification disclosures of these risks. And those risks are very much asset level dependent, not necessarily corporately. Corporate numbers or average numbers will show the exposure. So with that, the financial sector is directly exposed to water-related risks in the mining industry. And thank you for your attention here. We're open for questions, and if there are any further questions, you can contact me, and here are my contact data. Is below 50% good or bad? Below 50%, I assume that relates to the question or to the slide where I showed the benchmark of consumption. Again, it will depend on the location where you operate. There are locations where water stress is not much of an issue, and you have to take the local context in consideration and the size of the operation to understand whether that is good or bad. The sources of water demand, consumption, withdrawal. What are the sources of water demand, consumption, withdrawal? Typically, there are I would say traditionally, you would see in a mining operation a definition of two, maybe three water qualities being required, where the bulk of the water is considered as process water, and not necessarily there are that many water quality requirements for that. There are specific water uses that require very good water quality that can be in final product in solvent extraction, electrowinning, for example. Also potable water requirements, water used for reagents. Those are typically not that many, not that much of a stream that you would require for that. What you would see typically, depending on where you're operating, you would start with to use the water that you have to manage in some way. And with that, I mean, if you're operating an underground mine and that mine is affected by water that's entering in the shafts or the underground operations, that water has to be pumped out, and that would be the first source of water that you will have to look at. Then it will depend on whether the water balance that you're operating, if the total amount of water if you still need more water than that, you may have to look for other sources. But typically, I would say that the groundwater sources are typically those sources that have to be managed first, and surface water sources are the ones that are more exposed to climate related risks, and the ones that you probably don't want to be dependent on too much. The question, Laurie, how does Skarn assess water-related risks in wetter climates, where the main concerns are more related to water quality concerns and social and environmental impacts of those? It's a pretty interesting one. And Laurie, located in Canada, and especially in Canada, with a lot of the gold mining, we do monitor what's going on with the water discharges at sites, and very often that relates to potential contamination of metal contamination, sulfate contamination, but especially cyanide and nitrogen contamination that has to be managed. I think the potential impact of that relates mostly to having to install or manage those discharges in such a way that you reduce as much as possible your capex and opex associated to treatment plants. And at the same time, you don't want to be exposed too much to potential variations in water availability. And that's especially also in Canada, where you would see that, where in the winter time you don't have too much surface water available. So that's in general, we don't work specifically on the management of the water itself during the year. We do see how that is the variability of water availability is an exposure. Have operations that experience floods and droughts over the course of a year been evaluated? That's an interesting one. Yes, and then we come immediately with a challenge from our side to evaluate that. And that relates to not all the mining companies directly declare that they are facing a flood or a drought impact in their production. But in those cases where it has happened and where there is data available, we have checked what our model says against what the loss of production has been declared, and in several cases we were, I would say, pretty close to the probability that we indicated. You should, however, take into consideration that what we are calculating in our models are probabilities and not necessarily happen every year. On next question, I think I'm going to take 1 or 2 questions more, and because we're already over the 30 minutes now. Regarding financial water efficiency, is there an expected ratio per area? More water-stressed sites should have a higher indicator. As I mentioned, the indicator used by UN is based on water withdrawal, and that specific indicator, what I've seen so far, is that the locations, the more wet locations, they have a higher withdrawal volume, and thus they are somehow artificially they are reducing the water impact efficiency because of that, because they have to handle that water as a withdrawal. If you look at it from a consumption perspective, typically the more drier operations, as I also showed in the case of copper, they have managed in time to gain a pretty good operational water efficiency in cubic meter per ton of ore processed. But they are exposed to higher, especially evaporation rates, and that is limiting the total consumption, an optimum consumption intensity. In that sense, probably the more wetter environments have better potential to improve their consumption intensity, but they're not necessarily driven to do so because of the cost associated to it. Do we have a spatial map that shows assets regions that are water stressed? It would be helpful to know a measure of water use intensity relative to water stress. For example, a mine in a water-rich country like Canada may have less impact locally than a lithium operation in Chile. I wanted to make a comment here on, so there are other tools available that that show on and they show on maps what a location water stress might be. I mentioned, for example, aqueducts and WWF with the water risk filter. However, they do not necessarily take into consideration the asset level impact of the mine at that location, and that is where we do an overlay with our data. And in fact, in our data products, we include the aqueduct water stress indicator as well to have that as a view. It is a good, I would say, first approach to have a feeling about the external environment on water availability and water stress, but it doesn't necessarily take into consideration the specifics of the water operation, especially the size and the water consumption and the water use it has. In that sense, we are not developing a map per se, but we do in the data set we share the location and the aqueduct water stress indicators for the mines that we are evaluating. I'm going to do one last question. Does that indicator should well, depending in terms of, let me see if I that relates to another question by Nicholas. Does the indicator evolve depending in terms of a water efficient technology? Okay, if this relates to the financial water efficiency, if I understand it correctly, he is asking whether if there are the water efficiency technology implemented at each mine site, will that change the financial water efficiency? Again, if we're talking about withdrawals, it could be if you are incorporate works such as the separation of contact and non-contact water that enters into your operation. If we would convert the efficiency indicator to a water consumption indicator, then yes, directly there is a direct relationship between the operational water efficiency and the financial water efficiency. And with that, I think I have answered most of your questions. And with that, again, if there are any further questions, please let me know. My email address, I shared that already. And thank you for your attention and looking forward to a next webinar. Thank you. Good afternoon.